So, further on testing. Test-driven development is a programming technique where you write test code before implementation code. Test code is written to define the desired behavior of your program. The test output provides descriptive error messages that inform the implementation of your program. Okay. The red-green refactor cycle. One of the driving forces of TDD is the red-green refactor cycle. Red and green correspond to the color of the text that our test framework produces in the terminal while running the tests in our suite. Red signifies failing tests, and green corresponds to passing tests. Use this red-green refactor diagram to help you as you read the steps below. Okay, let's take a look. So we start, we write a test fails. Write minimal implementation code. Test passes. We refactor implementation and test code. I do not understand any of this. So, write tests that describe the intended behavior of implementation code and then compare developer expectations with the actual results of implementation code. The test should always fail at first because the implementation code for the desired behavior will be written in response to the failing test. What? Oh, yeah, okay. Write just enough implementation code to make the test pass. The tests return green because the implementation code executes the intended behavior described by the test in the red phase. Refactor. Clean up and optimize code following the characteristics of a good test. Refactoring involves actively considering test and implementation code and making revisions to the code base. The tests are passing and should continue to pass throughout this phase of the cycle. Do I understand this? No. Can I still try and do it? Yes. Okay, let's try. Locate the index.test.js file in your editor. It's here. This code has an error in it. You can identify the error by running the test suite and reviewing the output. Okay, npm test. So, missing parentheses after argument list. Sure. Based on the feedback, fix the code, run your test again. More problems. Suite calculate was defined, but no callback was supplied. So it's missing the suite test full title, blah, 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 was defined. Returns the sum of an array of numbers. So we need an assert. Sum of an array of numbers. I don't know what I'm doing, but I'm doing something. What is this? Oh. Maybe that wasn't the problem. Missing parentheses everywhere. Unexpected token on line 7. Or maybe it wasn't missing parentheses. Calculate was defined, but no callback was supplied. Supply callback or explicitly skip the suite. Um, blah, blah, blah. Throw new error. I don't get it. Wait, let's reset. I think I mucked something up. This gets closed here. This gets closed here. So this should get closed here. Yeah. What a weird way to do this. Like, oh, no, it's not. That is how you do it. Okay, never mind. But I still don't understand, like, what is it testing here? And why is it passing? This just creates an object. Huh. Okay, let's move on. Getting into the red. When we use the green-red refactor cycle, we write test code that fails, write implementation code to make the test pass. Consider refactoring the code. As you learn TDD, it may feel backwards to intentionally write and run code that will throw errors. In TDD, we react to the error messages by continually rewriting our implementation code so it behaves in the way that our test specifies. Imagine you were trying to create a method named initials inside of an object named phrase. The desired behavior of initials is that it should return the first letter of each word in phrase that is passed to it as an argument. Okay, so we first step to writing a test with Mocha is to use describe and it blocks to describe the desired behavior of a code. It's very important for tests to thoroughly describe the desired behavior with natural language. This will create the most helpful error messages and make it easy for you to understand the behavior that your test failed in executing. Before running our test, we would use an insert statement to compare the desired result of our method with the actual result. Test that would look like this. So we just do phrase initials method. It returns the first letter of each word in a phrase. Okay, so passing Nelson Mandela into the function or into the method should return an M. but it shouldn't. If we ran this test, we would get the following error message. The error message tells us that the error is related to the phrase initials code block. The reference error tells us that the error is thrown because we don't have a phrase object. In the next exercise, we'll show you the minimum possible code required to get this test to pass. But you also... Okay. Complete the test for calculate sum by writing an assert strict equal statement to verify that calculate sum 1 to 3 is equal to 6. When using npm test in the terminal, the test should fail since calculate sum hasn't been defined yet. Okay. Oh, strict equal. And this should return 6. And this should fail. Yes. Okay, because there is no sum yet. So then we write the something. So we're in the red. The red error message described the failure of our implementation code. So we can specifically address each issue that is preventing our test from passing. Let's look at the error message from our initial phrase initials example in the last exercise. Phrase is not defined. The error tells us that phrase is not defined. This is because we have not created an object named phrase. Let's do that now. And we run our test again. And the error should look like this. Phrase.initials is not a function. We're still in the red, but we have a new error. The error says the phrase initials is not a function. That's because we haven't added an initials method to the phrase object. Okay. Undefined assertion error. Undefined equals an M because your method doesn't return anything. Actual behaviors of the initial method. The assert statement we wrote looked like this. Sure. We expected the result of passing Nelson Mandela to phrase initials to be an M, but the actual result was undefined. This is because our method has not been programmed to return anything. Following TDD, the next step would be writing the minimum possible implementation code to make our test pass. In this example, that would involve adding a line of implementation code so that initials returns our expected result, which is NM. So return NM. What does that give us? Okay, it should pass. And we would be in the green, but that doesn't mean that our method is working as intended. If we enter Jody Williams, our method would return NM, not JW. We will address this issue when it is time, but following TDD, now that we progressed from red to green, we will move into the refactor phase. Okay, so in index and above line, blah, 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 exporting your implementation code, create an empty object named calculate. Okay. Const calculate. Ah. All right. So then run the test suite. Sure. Failed because .sum is not a function. So now we need calculate.sum to be equal to wait. Oh, never mind. Sum. So technically this should change now into undefined equals 6. Takes one argument. Or this should actually be array. Address the assertion in the terminal by making sum return the same value as the expected result you defined in your test. Okay, so return array. And this should fail. Yes. Oh, so now it matches with the function call. Okay, it's a little bit of backward approach, but I guess it makes sense. And now we would go back and write logic for the thing. Program the sum method to return 6. What? Address the by terminal making sum return the same value as the expected result. Oh, no, it's supposed to return 6. And testing passes it, but yeah, we're in the green. Okay. Okay, once all your tests pass, you can confidently refactor your code, restructure and improve it without changing its external behavior. The confidence comes from knowing that our tests will catch us if we take a misstep. When refactoring, it's critical to test early and often. If our tests turn red, then we know that something went wrong while we were refactoring, and we can undo those changes. A good place to start with refactoring is to structure the tests to reflect the 4 phases of a good test: setup, exercise, verification, and teardown. So let's consider the test for our phase initials method. We could rewrite the test with the setup, exercise, and verification stages to make it more expressive and maintainable. Input name, expected initials. Sure. We get the result. And then we check. Here we have rewritten the same test, but we have created variables to hold the values that we will used to test the behavior of initials and broken up the test into distinct phases, which are marked by the comments in the code. Now that we refactor a test code, we can refactor our implementation code. Our earlier code looked like this. Sure. In order to make our implementation code more expressive, we can change the name of the input argument of initials. Sure. A refactoring will look different for each project and each iteration of the red-green refactor cycle. In some cases, you won't need to refactor at all. Regardless, you should consider how you can improve your code. Although it is optional, you can set it up for success moving forward. Okay. Factory code to test to include step, setup exercise, and verify phases. Okay, Jose. So, our setup would be input. We do an array. 1, 2, 3. We also need expected result. Like this equals 6. Exercise. Const actual result. Calculate dot sum input. And then verification will just be a strict equal call to expected result and actual result. Okay. You set 3 variables, const variables, and describe the intended behavior of them using 3 variables. Result, and then input array. Yes. Descriptive const variable for the result of your method. Oh, I forgot. Actual const actual result. You just leave it like this. And then we do the exercise here. Rewrite your assert statement to compare the exercise result to the expected result. Missing initializer in const decoration. Const declarations must be initialized. Oh. Okay, sure. All right, so this worked, but Codecademy is not happy. What's up, Codecademy? Why are you being grumpy? Expected result. input array, and result. You didn't do it right. Assert strict equal result. Oh, you pass in the result first. And then the expectation afterwards. Still not happy. This is fine. This is fine. Calculate sum. Input array. Still not happy. What is your problem? You told me to write setup, exercise, and verify phases. And you yourself don't do that. This is just setup. Fine, replace. Let's move on. Okay, congratulations, you made it through your first red-green refactor cycle using TDD. The next step is to repeat the cycle to build more complete implementation of the initials method. Once you have a baseline test for your feature, you can start to write additional test cases that force you to write better implementation code. Let's consider the test suite for our phase initials method. We have one test that checks if phase.initial Nelson Mandela returns an M. Sure. Let's write another test that pushes us to implement a phase initial method that returns the first letter of each word for Nelson Mandela and a different name. To do this, we will add another if block to our code, and inside the callback function, we will again follow the setup, exercise, verification phases for writing tests. This time we will write a test based on the circumstance that our string passed into initials has 3 names. Here's what a second test for initials will look like. Sure. Although the new it block is similar to the existing example, the two together force you to implement a method that will return initials that pass both tests. The idea of TDD is to continue building tests and going through the red-green factor process until you feel confident that your implementation code performs as expected. Okay, so let's add another test to the describe that is supposed to return the sum of a 4-item list. Sure. Okay, so expected result. expected result. Return the sum of a 4-item list. Inside the block and setup exercise, blah, blah, blah. You should see the following error message when you run your test suite. Okay. If we do 22, right? That's the expected result. And then const input here's the sum of a 4-item list. Is it that simple? Equals, okay, let's say 10, 10, 1, and 1. And do const result equals calculate dot sum input array. Equal result expected result. So if we run this, yeah. Yes, I did add another it block. Is it semicolon? No. What is your deal? Oh, you're just unhappy about the numbers that I chose. 4, 5, 6, 7. Is that the case? I think so. 4, 5, 6, 7. Yeah. Okay. So now we would go back here. All right, let's move this. Red to green 2. Now that we have tests that cover more than one condition, it is time to program the actual behavior that we want our initials method to execute. Let's think about the current state of phrase initials. We have one passing test and one failing test. That raises the following error when you run the test suite. Sure. That is not surprising, considering our current implementation always returns NM. To write a more complete implementation that would get us back into the green, we could write something like this. All right. So we have initials array. We split the thing into words, and then for each word, we just push in the first letter into the array. And then we rejoin it. Okay, we'll successfully pass the test we've written. Each additional test pushes us to build a complete implementation of the initials method. All right, so you're going to write returns the actual code to calculate the sum of the input array so that your implementation code will pass both of the tests you have written. Run the test suite to get the error message that will lead you towards writing the most concise production code to make your test pass. Okay. Okay, so instead of return 6, we can take the input array and do for each so input array for each number. We want to do no return here. We'll do let sum. And we can do sum plus num. No. Plus equals? Plus equals. Plus equals num. And then we return sum. Oh, npm test. Oh, unexpected token dot. Excuse me? Bum. Semicolon? Missing? Yes, but now we're failing both of them. Both of them. Is it just plus, maybe? No. Undefined. Oh, the return is in the wrong place. Not a number. What? We have the input array. For each. Did I forget how to use for each? Maybe. No. I don't think I did. Sum 0. On some function. For each. Convert a for loop to for each. could use the reduce, but yeah, array for each element equals sum plus equals element. Like, for formatting reasons, let's do this. Where was it? Is this JavaScript? Yeah, it is. And then we return the sum. Hmm. Not a number. What? What if we do equals 0? Maybe we can't sum to a empty thingamabob the way we defined it. Yeah, okay, that was the problem. Okay. So we're back in the green, which means the next step is to refactor the code so that your tests are fast, complete, reliable, isolated, maintainable, and expressive. Also, you want to make sure your implementation code is descriptive and efficient. Sometimes refactoring can take place in test and implementation code, either one or neither. The purpose of the refactor phase is to think critically about the code you have and decide whether there's anything unnecessary, redundant, or that could be done more clearly or efficiently. I see. So refactor your code in index.js by replacing the current implementation code inside calculate.sum with a function that uses the built-in JavaScript method reduce to accumulate the total value of an array of numbers. What was the reduce? Just do const blah 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 array reduce accumulator and current value. Accumulator plus current value, initial value. Don't remember how to work with this. Value resulting from the previous call. Oh, so 0 and 0. Wait, no. Yes. I think the current value is not necessary. We just do 0 and initial value of 0 as well. I think. So we get rid of all of this. And we can do just const sum equals input array dot reduce zero zero. Wait. Accumulator current value. The value resulting from the previous call to callback function. The first call, its value is initial value. The latter is specified, otherwise its value is 0. Maybe we don't even need to do anything here. Current value. The value of the current element. On the first call, its value is array 0. If initial value is specified, otherwise its value is array 1. That's fine. Current index and the array. Wait, we can just do turn and put array dot reduce. Will this work? Maybe? No, undefined. Wait, I wrote this before. Uh, ba- 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 ba. Get max. Do we need to specify this whole shebang? Oh, unexpected token. Discloses this, discloses this. Hmm. So here we have an array. What? Reduce. Oh, we need to pass it a function. Right. Is it X? It doesn't like sum things itself. It just passes a reduction function. Current value, current index, array, initial value. Do we just write a lambda function. Total price, items reduce, accumulator, item. And then return accumulator plus equals item.price. My brain is heavy. At its heart, reduce iterates through each element of an array, applying a user-defined function, aptly named the reducer, to both the current element and an accumulator value. This accumulator starts with an initial value you provide, or defaults to the first array element. Gets updated with the return value of the reducer in each iteration. Ultimately, the final state of the accumulator becomes a single value returned by reduce. Think of it like sculpting clay. Imagine shaping a piece of clay. Start with a lump and repeatedly apply pressure in direction, transforming it in blah 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 blah. Sure. You have an array of objects representing products. You want to calculate the total price of both products. The traditional approach, and then using reduce. Products that reduce. Callback function receives two arguments. Sum, the accumulator, initially set to the value of 0, and product, the current product object. Oh, so this just does the anonymous function thing? Yeah, I'm watching you. Don't you dare dig at your bed. Product price. Sum plus product price. Theoretically, this should work. No. Missing thing after argument list. Oh, I have one too many, I think. Yeah. I still don't get reduce, but I got it when I separately defined a function for it to use. So you just then pass the function, and then you pass something. But now, like, I'm passing two variables. that I'm not even using, not even defining. Like, okay. The reduce method takes a callback function and an optional initial value, 0 in this case. Callback function receives two arguments, sum, which is the accumulator, initially set to the value 0, and product, which is the current product object. Hey, don't eat your legs. Don't chew on your legs. You have toys. Door. Don't chew on your legs. You have toys, you weirdo. He's like, I'm not chewing. I just have the leg in my mouth. Are your nails getting long? Is that why you're chewing them? We clipped them last week. They're not that long. All right. Well, let's move on. This work. Edge case. Now that we have written and refactored a few tests, it's time to consider edge cases. An edge case is a problem or situation that occurs only at an extreme, maximum, or minimum operating parameter. You can think of these as special cases that you need to account for. I was looking at him, and it looked like he didn't have his foot in his mouth, but he did. And then he slowly pulled it out. Uh, take our phase initials example from earlier. What happens if we pass initials a number instead of a string? We could write a test and then implementation code that responds to this behavior by raising an error message that instructs you to apply to only use strings. Okay. So we have our input as a string, as a number. We call the function with the name input. Assert throws exercise. Oh, we do it as a lambda function here. So we don't have to do it here. Why these slashes here? After getting our intended error message, we would write just enough implementation code to pass the test, which in this case would be adding the following phrase initials, two phrase initials. If type of input name does not equal string, throw new error, error only use string. Oh, so these have to match. Okay. So now you will write your own test and implementation code for an edge case in your calculate module, which covers the behavior of an empty array passed to sum. Sure. Steal this. Toss it here. So our expected result should be, if we pass it a empty string, turns 0 for an empty array, and we do 0, the input array is empty. This should remain the same. And then we should fail. Yes. Okay, so here you just add an if clause, input array is equal empty. Oh, we're checking the length. Sure. Is equal to 0. Zero. Then we throw a new error. Oh no, we just return 0. Okay. Use strict equality. Sure. Okay. So, review. We've just covered test-driven development with Mocha. At a high level, process is write the test. Start with the test, describing the functionality we would like to see. Fail the test. Write code in response to the test that fails. Pass the test, refactor code. Okay. Chai. You're presented with the documentation for the Chai assertion library. This is helpful if you want a comprehensive resource for this library that pairs with many JavaScript testing frameworks. Instead of trying to remember it all, use this documentations as a readily available thing. So, Chai and Mocha. What is Chai? Assertion styles. Expect. Require. Seems like an entirely different framework. All right, next. Okay, which of the following statements about TDD is true? TDD is based on the idea that you can fix your code at any point, so you should try to get every behavior you want into a project and then test the components as a whole. No. One of the keys to TDD is that you only write implementation code in response to the error message that your test revealed. It is important to make sure you're addressing one behavior at a time. Yeah. Which of the answers is the correct description for test-driven development? A programming technique where you write your implementation code first, then create a suite of tests to support its future development. Quite the opposite. Write test code with descriptive error message to inform you the implementation of your desired feature. Yeah. Which of the following is correct definition of an edge case? An edge case is behavior that is most important to your program. An edge case is a perfect example of the main functionality of your program. No. The problem or situation that only occurs at an extreme minimum maximum operating parameter. Yeah. Which of the following describes the red phase of the red-green refactor cycle? Revise your current code base to be more flexible. Programming the minimum viable implementation of your feature. Yes. Wait, what? Write an expressive test describing the desired behavior of your code. Isn't that the green cycle? The green phase? Because, like, you're in the green, so you add more tests. When you're in the red, you program the minimum viable implementation of your feature. Codecademy, you so crazy. Okay, which of the following is an example of refactoring in TDD? What's up? The ceiling, the sky, most of the air, birds, planes, planets, stars. What else? Parts of buildings? We finished, well, I guess we didn't really finish, but forgot clouds, I think. Probably, yeah. No, we're doing a quiz. We finished the theory, I think. Let's take a look at the syllabus. Yeah, TDD. We're almost done with JavaScript testing, and server testing should be next. How's the soup? Was not bad at all. What kind of soup, though? Chicken soup? Is this like the traditional thing to make when you're sick? Which of the following is an example of refactoring in TDD? Just some chicken soup. Yeah, okay. Yesterday, no, not yesterday. The day before yesterday, we made mushroom soup. It was amazing with garlic bread. So tasty. Creating new behavior that you realize your program needs. No. Writing a test that describes intended behavior of your program. No. Excuse me, replacing a oh, sure. Soups, when made well, are so good. Yeah, my girlfriend made, it was not the previous soup, it was the one before that. She also made mushroom soup, and it was just amazing. Holy crap, like the best soup I've ever had. Even though we made like mushroom soup multiple times before, but something this time turned out so well that it was just like, I could not stop eating. Replacing a for loop with a built-in JavaScript method, such as reduce, because it is more efficient. Yes, okay, refactoring. Which of the following is the correct definition of an edge case? Edge case is a problem situation that occurs only extreme operating parameter. Yeah. Which of the answers is the correct description for test-driven development? Programming technique where you write test code with descriptive messages to inform the implementation of your desired feature. Where you write your implementation code first. You write test code first. Which of the following describes the red phase of the green? So, okay, hey, Nick, I know which answer is correct. Which one do you think is correct for this question? I want to test something, whether I'm crazy or is Codecademy crazy. Can you see? I can zoom in. Either fourth or third. I'd say fourth. Now I forgot which one I picked last time. Yeah, I picked that too. It doesn't make sense, right? Because the red phase, you're in the red phase. What does that mean? It means your tests aren't passing. So, what do you need to do to make that pass? You need to program the minimum viable implementation of your feature, right? And not like write another expressive test describing the desired behavior of a code. Like, no. If you're in the red phase, what does that mean? It means you're getting errors for the tests that you already have. That's why it's red. Because errors are red. Isn't it the time where you implement the tests? That's exactly what I'm saying. Like, if it's red, it means you already written a test and you're not passing it because it's like throwing errors or like something isn't passing. So you're in the red. You already have a test and you're failing it. So to not fail the test, you go to the implementation and you just write some minimal code to pass the test. And then you're in the green. And once you're in the green, then you write another expressive test to test for something else. Like, wait, let's go actually back to where they describe it themselves. Where is it? I think it's here somewhere. Red-green refactor. The red-green refactor approach helps developers compartmentalize their focus into three phases. Red, think about what you want to develop. Green, think about how you make your test pass refactor. Think about how you improve your existing implementation. Wait, where is it? No, this is equality. The next after one. Copy pasted from Codecademy. I want to see it with my own eyeballs. Not that I don't trust you. Okay, here. So the first thing is red. Write tests. What? Okay. You repeat the short cycle of following. Write a test. Red. Get the test to pass. Green. Okay. Okay. So. Okay, maybe I get the logic here. But it's such backwards logic too. I don't know. It doesn't compute in my brain. Wait, so red is write a test. Okay, okay, fine. I would say that writing the test causes the red, but okay. I don't know. Maybe I'm just being picky, or maybe I'm just tired. I've been streaming for like almost 8 hours now. So, which of the following describes the red phase of the green? First question. Write an expressive test describing the desired feature. You are grinding live streaming in Codecademy. I guess. I'm getting used to it slowly. Which of the answers is the correct description of test-driven development? Rewrite implementation code. Nope, this one. Assuming you have the following implementation code and test output, which test would produce these results? So this is just basically return 6. And we're getting assertion error where 6 is equal to 22. So we're looking for an if statement where the solution is 22. Insert equal solution 22 input array this. Result calculate some input array. Yes, result solution. I think it's this one. Let's see, why is it not this one? Because it doesn't have an assert. And why is it not this one? Oh, it's not this one because it doesn't have an it statement. So it's this one. Yeah. Which of the following is an example of refactoring in TDD? Replacing a for loop. Edge cases. This. Which of the following statements about TDD is true? Is based on the idea that you can fix your code at any point? No. That you only write implementation code in response to your error message that you test revealed. Yes. Okay. Factorial feature. Is this a project? Yes, it is. Yeah. Okay. I think it's a good idea to finish for today because it'll be more effective to tackle this tomorrow when some of the knowledge settles. But I think we did good today.